So good evening everyone. Today we'll be doing the radii of permitted orbits. You can see in the image very well. There is an atom with nucleus plus Ze charge and an electron E minus, mass is m, and it is revolving around the nucleus in a particular orbit with velocity v. And you must know that is in the circular motion just because the centripetal force is being balanced by the electrostatic force of attraction. So firstly the work is to find the force which is acting over it. So force would be, as you know from the first chapter, K Ze is the charge on nucleus and E is the charge of electron, and upon r square. After calculating we will get kz square upon r square. Now as you know, or we can write as we know, centripetal force of electron will be equal to electrostatic force of attraction. So writing the formulas, equating the values, mv square upon r is equal to k z square upon r square. This is here, we have taken here. Now from here we will calculate the value of radius. It is the rule you have to remember, is always, it's an important derivation. We will get this value, we can mark it accordingly because we will be using it afterwards. So now the other thing that we have to do, we all know Bohr's quantization equation. So Bohr's quantization equation is a very important equation. Again, we know L is equal to mvr upon is equal to nh by 2 pi. So from here also we will find the radius accordingly, nh by 2 pi mv. Mark it again, we can mark it 3. Now what we have to do, we have to compare these 2 and 3. What we will get, kz square upon mv square, nh by 2 pi mv. We will find the value of velocity because we will be getting two values, firstly the formula for velocity and then radius. So velocity v is equal to 2 pi k z square upon nh. After solving you can solve very well, we will have velocity as this. Now we have to put this v in equation number 3. What we have equation number 3, that from the Bohr's quantization condition, as r is equal to nh by 2 pi mv, we have to put here. So nh by 2 pi m multiply nh by 2 pi kz square. You can solve it. So after solving it properly, we will get radius is equal to n square h square upon 4 pi square mk z square. What we can do, there won't be any cancelling here, so we will nh multiply nh, n square h square, and 2 pi m, 2 multiply 4, and pi multiply pi square, and m will be m as it is, and k z square. We were just checking any value left or not, so it is perfect. It is the radius for the permitted orbit. So it is the complete derivation you can see Firstly, we have to find the velocity using applying three equations in total. Then we will get the radius.